All right. Give me 1 second. Yeah, okay. Perfect. Okay, so let's go ahead and go through today. So we've looked at how to calculate probability. Basically, what we're going to look at today is how do you calculate probability when you're given those probabilities in a table. And so we're going to look at that. So here is an example. It says a two-way table shows data classified in two ways. So basically, it's data classified like this. The table below shows the distribution of lunch orders at a deli by sandwich and by beverage. The deli owner randomly chooses a customer to receive a lunch order for free. What is the probability that a customer will order a ham sandwich? So I'm looking for the probability that the person who orders it will have ordered a ham sandwich. So what I want to do is identify the total number of people who have ordered a ham sandwich. That's right here. That says total, right? Total number of people who have ordered a ham sandwich is 54. So I want to put that on the top. And he's basically picking anyone who has ordered lunch. So any of the people who have ordered lunch, so the complete total amount of people. The total people who have ordered a sandwich and beverages in total altogether is 137 people. So basically, out of 137 people who have ordered lunch that day, he wants to draw someone who has ordered a ham sandwich. So that's what we're calculating here. Put this in your calculator and you'll see that it's approximately 0.39 or 39%. So in two-way tables, basically what we do is we're not given the probability in the word problem, rather we're given it in the table. So we use the table to identify those probabilities. And so I want to find the probability of ham, so I'm going to take the number of people who ordered ham over the total amount of people who have ordered in general. Okay. But what if I have a conditional probability? I can still use this table to solve for conditional probability. So it says, find the probability that a customer will order an iced tea given that she has already ordered a ham sandwich. Well, we know that our given goes after that dash, so ham. What is the probability that they will order an iced tea given that they've already ordered a ham sandwich? So I want the total number of people who have ordered a ham sandwich, 54. And now, out of those 54 people who have ordered a ham sandwich, how many of them ordered an iced tea? Right there, 28, right? That says iced tea, ham sandwich. That means they ordered an iced tea and a ham sandwich. So I'm just going to put that on top. And then that I plug into my calculator, or I don't have to, I can leave it like that. If I wanted to find the probability, I could put it in the calculator. And it's going to be approximately 51%. Okay, so in two-table probabilities, you're just using the table to solve the problem. So here's some other ones we're going to look at. This says, what is the probability that a randomly selected 15 to 24-year-old is male? So the first criteria I want to meet is they have to be male. So they have to be male. And they're going to be 15 to 24-year-olds. Okay, so on the bottom, I'm going to put the total number of males I have. The total number of males, 156. And then I'm looking for those males who are 15 to 24. 22. And if I put that in the calculator, that's approximately 51%. Okay. What's the probability that a randomly selected male is 15 to 24? Well, that's telling me oh, okay. I see what I did here. I'm wording this wrong. This one goes on the bottom. And it's not 51%, it is 14%. So it says, what is the probability that a person selected is male given that they're 15 to 24-year-old? Oh, no. Sorry, I'm confusing myself. What is the probability that a randomly selected male, so I've already selected a male, is 15 to 24 years old? This one says, what is the probability that a 15 to 24-year-old is a male? So you can see how that's kind of worded different. And so that means that what I'm going to put in is a little bit different. So first I'm looking for the total number of 15 to 24-year-olds, which is 43. And then I'm looking for the total number of 15 to 24-year-olds who are male, and that is 22. And so that is approximately 14%. Okay, so basically I'm just using this table again to calculate these things. Here's another one. A senator is randomly chosen for the 114th Congress. What is the probability that a randomly selected Democrat or Republican senator is male? So I just want either a Democrat or a Republican, it can be both, who is male. That's what I'm looking for. If I were to select out of the entire population of Democrat and Republican senators, how many of them are male? So my total number of senators who are Democrat and Republican is this. So 44 times 54. And then the number who are male is this number, 30, 48. So that means I don't even need to consider these independent, which means I don't need to consider these totals. And I don't need to consider anyone who's female as well. I'm looking for Democrats or Republicans who are male. And so I put that into my fraction. And that is approximately 80%. Okay, so given what the probability that I stated in the word problem, then I know what to look for in my table. Okay. We can also use two-table probability to determine if two events are independent. Remember that two events are independent if the probability of A and B is equal to the probability of A. So if it is in fact equal, then I know that those two events are independent, right? That's what we looked at on Friday. And so this says a small airport collected data on departure times for the two airlines it offered. The two-way table displays the distribution of flights in thousands based on the airline and the departure time. Are departed early and flying on airline A independent events. So I need the probability of arriving early given that I fly on airline A. And I want to see if that is equal to the probability of being early. So again, a small airport collected data on departure times for the two airlines it offered. The two-way table displays the distribution of flights in thousands based on the airline and the departure time. Are departing early and flying on airline A independent events? So I want to see if these two are independent. They will only be independent if these two expressions are equal. So the probability of flying on airline A and arriving early and the probability of E by itself. So I want the total number of A, airline A, 60. And then I want the total number of early in airline A, 18. And then for the bottom one, I want the total number of people who have flown and those who have arrived early. Like this. And so I can go ahead and find those probabilities. And what I notice is 30 is not equal to 24. So that means these two events are not independent. In order for them to be independent, they have to be equal to each other. Okay, so for example, this one, it says Hotel Olympus and Hotel Athens each hired a batch of new workers. Atlantis hired a total of, and this, so basically all this stuff is created on this table. Now that we have all this listed on this table, we want to know a new employer at one of these two hotels is randomly selected. Let A be the event that the employee works for Hotel Athens, and H be the event that the employee is a hospitality professional. Are A and B independent events? So I want the probability that given that someone works in hospitality, works at Athens, and I want that to be equal to the probability that someone works at Athens. So like this. Okay, and so I want those to be equal. If those two are equal, then I have independent events. Okay, give me 1 second. Okay. So probability A given H. So I want the total number of people in hospitality. That's what H is. That is 300. And then those who are in or work in Athens and work for hospitality, 75. So 375, that equals 25%. Then I want the probability Athens. That is equal to the total number of people who work, 500, and then those who work at Athens alone, 125. And that is also equal to 25. Because these both are equal to 25, then those two are equal, and so those two events are independent. Okay, so in order for events to be independent, I want to make sure that my probabilities are equal. Sorry, that's the wrong. Equal. Questions? So basically what we're doing here is we're applying everything that we've looked at, the different ways to notate these different symbols or to understand how these problems are worded. So basically what kind of probabilities it's asking. And given what the probability is asking, we're going to use these tables to solve for those probabilities. And so the unique thing about these tables is that all your information is given in the table. You just need to identify or select what parts of information I need to fill in that probability. So here the probability of being in hospitality is 300, right? That's the total number in hospitality. But then being in hospitality and Athens is 75. And so I need to plug those in. And that's what I did. Solve for the probability. The probability of being in Athens, you want the total number over those who just work in Athens, the total. And then you want that probability. So everything's going to be given to you in your two-way table. You're just using your two-way table to plug things into your probability. Okay, questions? Okay. We'll go over some practice problems tomorrow. But if there's no other questions, you guys may log off, and I will see you guys tomorrow. Bye, guys.